Absolute advantage is the product that produces the most, whereas comparative advantage is the product with the lowest opportunity cost, meaning that you're able to produce more of a certain thing without wasting or giving up more of another thing. Next, to solve the next problem, it says, if they bake only cakes, then in a single day, Brett can bake 10 cakes while Joe can bake 5 cakes. If they only make pies, then in a single day, Brett can bake 15 pies while Joe can bake 4 pies. Who has the comparative advantage for each product? What would be the acceptable terms of trade if Brett made pies and traded for cakes? Okay, so Brett can only make 10 cakes as well as 15 pies. And Joe can only bake 4 pies and 5 cakes. So to find the opportunity cost, I would have to put my other over my output, which would be 15 over 10, and this would give me 3/2 if I simplified it. And then since my other cost would be the reciprocal of this, I would simply flip the numerator and the denominator. And then to follow the same process over here, I would put my 4 over my 5 to give me 4/5. And then flip that to get me 5/4 of a cake. So essentially, one cake would cost me 3/2 of a pie. One pie would cost me 2/3 of a cake for Brett, and for Joe, one cake would cost me 4/5 of a pie, and one pie would cost me 5/4 of a cake. Looking at the comparative advantage, if you remember our previous definition, this is going to be the smallest number because you are producing the most without spending the least. So if we look at our category for cakes, the smallest number here is going to be 4/5. And if you look over here at pies, our smallest number is going to be 2/3. Therefore, if we're looking at cakes, Joe would have the comparative advantage. 4 cakes. And if we're looking at pies, Brett has the comparative advantage. Pies. And one person can't have both of the same comparative advantage. One is going to have one and one is going to have the other. So essentially, if you were to find out one of them first, you could just assume that the other one has the comparative advantage for the other product. Moving on to find the terms of trade if Brett made pies and traded for cakes. If you looked at trading for cakes over here, and you drew a line between your two values, any number in between 2/3 and 5/4 would work to benefit both. So any number between 2/3 and 5/4 would work. So an example would be 1 pie for 1 cake. Now, this problem is essentially an output problem, meaning that you're looking to see which person can produce the most amount of cakes or the most amount of pies. However, if you turn it into an input problem, now you're looking at the amount of hours that it would take for each person to make a certain amount of cakes and a certain amount of pies. So in order to calculate the input values, you would have to do your input over your other. So you would have 10 over 15 to give you 2/3. And then again, reciprocal would be 3/2. And then for over here, your input over your other, which is 5/4. And then to get the reciprocal of that, you would just flip that around to get 4/5. even without calculating anything at first, just looking at the amount of hours that it took to make the cakes and the pies, I would just be looking to find the smallest number for each, because that's the amount of hours that it would have taken me to produce that certain thing. And essentially you want to have the smaller number because it took less amount of hours to make it. So for absolute advantage, Joe would have both the absolute advantage for cakes and for pies. Now for comparative advantage, you would simply be looking for the smallest number once again. So here you can see that 2/3 is smaller than 5/4, so that would be our comparative advantage for cakes. And for pies, if you look, 4/5 is smaller than 3/2, so Joe would have the comparative advantage for pies. So for Joe, it would be pies, and for Brett, it would be cakes.